Today we're going to talk about congruence and similarity, which you learn early on in geometry, and then special right triangles and your trig functions. So things like sine, cosine, and tangent, which you learn towards the end of the year in geometry. So as far as congruence goes, congruent objects are exactly the same. So you have equal angles and equal sides. Typically, if you were looking at a problem with congruent figures, they would just be oriented differently. So you might see, I don't know, a figure that's a square that's kind of tilted and then maybe this way. And it might give you the fact that they're congruent and give you one measure over here and then ask you to find its corresponding side in the other figure. So just knowing that everything's the same in both congruent objects, angles and sides. When you have similar objects, they will have the same angle measures, and then the sides are proportional. So you would have some ratio in terms of their similarity. You have two formulas for special right triangles, and these are given in the SAT math formulas, which I showed you guys yesterday. They're in the top right-hand corner of the provided formulas. So you have your 45, 45, 90 triangle where your two legs are the same, and then the hypotenuse is that leg times the square root of 2. You can find these using Pythagorean theorem in some cases, but it's often faster and easier to use the special right triangle formulas. Over here, you've got your 30, 60, 90 triangle. So the shortest leg is across from the smallest angle. So across from 30 degrees is x. Across from your 60-degree angle is that shortest side length times the square root of 3. And then across from the 90-degree angle is 2 times the shortest side length. And again, all of those can come from the Pythagorean theorem. It's just a little bit faster to get them from the special right triangles. So if you ever see a problem that's working with the 30, 60, 90 triangles, it is beneficial to look to the formula sheet. It's probably going to be a time saver for you to solve for those missing pieces. So here's an example. They tell us that a triangle is equilateral with side lengths of 2. So I'm going to draw myself a picture here. Equilateral means equal side lengths. And so here it's not quite equal, but we're just going to go ahead and go with it. So we've got side lengths of 2. And if something is equilateral, this also means that all of the angles are equal. So these are all going to be 60-degree angles, so that they all add up to 180 degrees. So remember, all of your angles in a triangle have to add to 180. I have 3 angles, and that's where I got that 60 degrees from. So I want to find the altitude of this triangle, so that's the same as the height. And if I just kind of pull out half of this triangle now, I'm looking at the altitude, which I'm trying to find, 90 degrees here, 60 degrees here. And then this angle up top is half of this 60-degree angle. So this is 30 degrees. I know my hypotenuse is 2. And then I've cut in half that bottom. So this is a 1 here. So there are 2 ways you can go about this. I can use my Pythagorean theorem. I can say 1 squared plus my altitude squared equals 2 squared. Again, remember that that hypotenuse is always the c in the Pythagorean theorem. So it's going to be 1 plus a squared equals 4. And then I can subtract the 1 to get a squared equals 3 and take the square root of both sides. And that'll give me an altitude that's equal to the square root of 3. If I want to use my special right triangles, from the previous slide, my special right triangle told me that if I have a 30-degree angle, this side, the shortest side is x. Across from my 90-degree angle is twice that size. And then this over here across from my 60-degree angle is going to be x times the square root of 3. So if I kind of equate that to what I have, and this is what happens with those similar triangles or congruent triangles on the SATs as well, they're just oriented differently. So if I look across from my 30-degree angle, that's 1. Across from my 60-degree angle was the altitude, so that's this here. Well, I know x equals 1, so that's 1 times the square root of 3, or just the square root of 3. That's what I was looking for here. And just so we can fill in that remaining side, across from the 90-degree angle was the 2. So across from the 90-degree angle, 2 times x, that was 2 times 1, or 2, so it matches up. So you also are going to run into trig functions potentially on the SATs. So a couple of things here. You want to make sure your calculator is in the right mode. So that's degrees or radians. And then just remember which sides your sine, cosine, and tangent relates. So if you remember your acronym SOHCAHTOA, the sine here is going to be your opposite over the hypotenuse. So we can see here angle theta opposite over hypotenuse. Your cosine function is adjacent over hypotenuse. So again, here's your theta, your angle. Adjacent means touching or next to, and then again, hypotenuse is the longest side. And then for the tangent is opposite over hypotenuse for the TOA part of SOHCAHTOA. So here, opposite over adjacent. I think I said opposite over hypotenuse, so opposite over adjacent. So here are some examples. In this first triangle, we want to find the cosine of angle Z. So cosine is adjacent over hypotenuse. So again, adjacent means next to. Now there are two sides that are next to angle Z, but one of them is the hypotenuse. So you want the one that's touching the angle that's not the hypotenuse. So that would be the 8. And then the hypotenuse is the 17. Remember, that's always the longest side or the side that's across from the right angle. And your answer might be written as 8 over 17, or you might see the decimal value. So if you needed that, you would just type that into your calculator. If it was a grid-in question, you can grid it in either as the decimal value or the fraction. Question 2 over here, the tangent of Z. So tangent is opposite over adjacent. So here's my angle Z. So opposite of Z, I have to go through the triangle to find it. That's the 24. And then adjacent, remember, means that it's touching, but it's not the hypotenuse. The hypotenuse here is 26. So the other side length that Z is touching is the 10. So 24 over 10, your answer probably would not be 24 over 10. It would probably be reduced to 12 over 5. Or again, you can put that into a decimal value. You do want to be careful on the SATs if you are gridding that in. You cannot grid in mixed numbers. So you don't want to convert that to 2 2/5 and then try and grid that in, because it's not going to work for you. So you either need the improper fraction of 12/5 or you need to convert to a decimal. So your assignment for today is congruence and similarity, and then right triangle trig on Khan Academy.